Easy for Assalamu alaikum, everyone. I think we should start because it's already 9. So I hope all of you are doing well. Just, can you all hear me?
Yes,
Yes, we can
Doctor,
hear you.
clear.
Okay, so
Yes.
let me just talk about the exam. So let's talk about the bigger portion. I already mentioned that there will be one question from queuing and simulation, right? I'm talking about the essay and the problem part. I already discussed that uh, uh, in the class. There was something I didn't cover earlier, and that's why it's very important for you to attend this session. I'm going to talk about that. It's not very difficult, very easy, but please make sure that you understand that very well. Okay. I Not everyone is here, so I'm hoping that you can share this knowledge to your friends. By the way, I've already shared the document through Muhammad. So you may already have the practice problem there. So there will be two numerical problems. Okay. So I'm going to first talk about that, and then I'm going to talk about in terms of preparing for the MCQs. So we only have 17 now. Are you expecting more people to join? Do you want me to wait for a couple of minutes, or shall we start talking about it?
Whatever suits you, Doctor.
For me, of course, earlier the better, but just I don't want people to miss. Please make sure then what we discuss here, some of you then communicate. Uh, the problem is at least one queuing. We already discussed that in the class, but the other problem that I will be talking about is was not covered in the class. So can you please send message on your group that please join within like 2-3 minutes,
Working on it,
so that
inshallah.
at least most of you join in. So I'll wait for like around 3 minutes, maybe 2-3 minutes, and then we'll start. Okay, so let me do something. Let me first talk about the queuing problem, which you already know. And in the meantime, I hope more of your friends would join in. Uh, for the queuing problem, uh, you have done that during your project as well. Is that uh, a situation will be given to you? Are you all here attentive?
Yes.
Okay, okay. So a simple situation will be given to you. Okay, something like this. So consider a single server situation. Data is collected for the customer arrival for 20 minutes as well as service times for 30 customers. It's exactly the way you collected the data for your projects, which are presented in tables below. Okay. The queue follows first in, first out, FIFO discipline, while the customer population is considered infinite. The customer arrive independently while service times are also independent of each other. The whole reason for giving this extra information like first in, first out, infinite population, independent arrivals is just to tell you that it is an MM1 queuing system. Okay. Why we needed to know that? Because if you look at the lectures, we basically looked at two possibilities. Number one, MM1 queue and then MG1 queue. So that you know that it is an MM1 problem. So if you have arrival data on the left side, this one of the things that you needed to find is lambda, and the other thing you needed to find is mu in such problems, especially MM1 problem. So uh, lambda and mu are both rates, which is like customers per minute. So if you look at this thing, the thing is given in like each minute how many customers are arriving. So this is basically a rate. Customers per minute, customers per second minute, customers per third minute, right? So if you take, all you have to do is simply to take the average of all the numbers. So it's 3 plus 2 plus 0 plus 2 plus, sum them all up and divide that by 20 minutes. So this will give you lambda. So lambda is 1.45 customers per minute. I didn't write it here, but it should be customers per minute. Are you all okay with that? So just taking average, because your actual data is in number of customers, so customers per minute will give you lambda by taking the average. Now,
So
if you
this,
look at the
doctor, will be given.
say again,
These tables will be given.
yeah, this is the data which will be given to you.
Good.
Now, on the other side, you see not the customers, but the times, service times, right? So when you take the average of that, it's not the rate, it's actually the time. And I told you that, to convert arrival time, you have to make it 1 over lambda, and to convert the service rate to service times, average service time, you have to do it 1 minus mu because it's already time. So what, by taking the average, what you're calculating is 1 over mu. Why? Because it's not the rate, it's the time. You can see it here at service times. Okay. So again, the thing is very simple. You just take the average 0.3 plus 0.9 plus 0.1, 0.3 plus 1.2, and all of it divided by 30. So what you will get is 1 over mu. Because you have estimated 1 over mu, so to find mu, it's so easy. You just do 1 over 0.67 and you'll get mu. Okay. So I hope this is very clear. By using this data, you have now found both lambda and mu. So the mu thing is clear to you, all of you? Okay.
Yes.
So I hope this is clear to you. Now the rest, this I think what is the most important part that I just explained to you. What's the first question that potentially can be asked? What is the customer arrival rate? You already I showed you how you can do that by using the data. You already found lambda to be 1.65. Okay, customers per minute. By the way, there's a small error here. It should be customers per minute because it's the rate. Okay. Now, service rate. What is the service rate? Do you see here we are asking about the rates, arrival rate, customer rate. Make sure if I ask about not service rate, service time, then you should give me 1 over mu. Okay. Or if I ask you about inter-arrival time, then I'm asking not about lambda, but 1 over lambda. So please read carefully whether I'm asking about the rate or the time. If I'm asking about the time, then you should give me 1 over lambda or 1 over mu. Or if I'm asking about the rate, then you should give me lambda or mu. Okay, I hope this is very clear. Now the next question is, in standard candles notation, how do you classify the problem? How do you classify the problem? I told you, you just have, I gave you all the description: infinite population, independent arrival, independent service. The keywords are independent service and independent arrivals. When you see these two things, it means that we are looking at MM1. Otherwise, independent arrival and general distribution for service, then it's MG1. Okay, so that's the only two possibilities that we have discussed in the class. So, it should be straightforward. Now, here's C. Yes. Yeah. So, I told you there are only two things. Number one, do you see customer arrival independently and service times are independent? We discussed that quite a lot in the class. If you talk about independent arrival, independent service, then this basically is telling you that you are looking at MM1Q. If it says customer arrival independent but service is not independent, it is following some other general distribution, then it is MG1. Okay, for example, and if it says customer arrival independent but deterministic service time, then it's MD1, deterministic service. Okay, is that clear, Said? Now, what percentage of time you expect the server to be busy? Now, this question can be asked in so many different ways. I can ask, what is system utilization? Or I can ask a question, what percentage of time you expect the server to be busy? It means the same thing. It always means the same thing, right? Because utilization is the time when server is busy. So if you remember, there was a formula for it. Anybody remember the row formula, the row? Anybody remember the formula for that? So it was, I'm going to write it here. You should go and read the slide, but it says rho is equals to lambda over mu. Can you see in the chat box, please? Rho, which is this symbol, P like symbol, is equals to lambda over mu. Okay. So what is lambda here for us? Lambda is 1.65, mu is 1.5. By the way, there's a small error here. This 96.66 is not correct. Because when you do lambda over mu, I think we did mu over lambda, so it was an error here. You get something greater than 100%. So of course, because greater than 100% basically means 100% time busy. So the question is this queue stable? And you know the answer to that. Anybody remember the criteria for that? Yes, that's what I'm talking about. So if lambda over mu, lambda divided by mu is strictly less than 1, then it is stable. If it is lambda over mu is greater or even equals to 1, then it is unstable. Okay. So this was the criteria. So anything greater or even equal, the queue is not stable. So if this number is 100 or over 100, what would be your answer? Your answer would be no, the queue is not stable. By the way, there's just an error, and please, when you're solving it, please do not assume that these numbers are correct. I think, quickly writing it down, whoever did that, we reversed the lambda over mu. Instead of lambda over mu, we did mu over lambda. Yeah. Yeah, that's what I'm saying. Or maybe either the calculation, there's a problem. Yeah. Okay, so it should be 1.45, not 1.65, right? Is that what you're saying, Mohammed? Okay, then it's the typo is here in the lambda. When you take the average, I think what he's saying is that it should not, it should be 1 point, oh here, 1.45 is the correct one. Oh, okay, I see, I see. Now I think I understand that. Basically, the error is here. It's not 1.65, it's 1.45, right? So then it's 96.66 is correct. So in that case, the Q is stable, okay? And then these formulas, as I mentioned in my announcement, that came from the course reader. These formulas will be given. Yes, Said. Because it's you just mentioned that 100%. You said it's the criteria is lambda over rho has to be less than or equals to 1, right? So when you divide 1.45 with 1 point, which is lambda, divided with mu, which is 1.5, use your calculator and tell me what you get. Use your calculator and you tell me what do you get. Can you divide 1.45 with 1.5? Yeah, take your time. 4.5 divided by 1.5. 1.45. You see in the chat box. See in the chat box. 1.45 divided by 1.5. See in the chat box. Mohammed has just I put it back. He's telling you, what do you get? 1.45 divided by 1.5. Don't tell me near to and tell me exactly what you get. It's 0.9666. So now you convert that into percentage. So 100 you multiply. So that's why we have 96.66%. Yeah. So it is stable. Now, other formulas will be given to you. What is the average number of customers? Okay, which is the formula is already given to you. N equals to rho divided by 1 minus rho. So all you have to do is to put the row values. By the way, don't put that in percentage. Or you can, if don't put that in percentage in these formulas. Okay. Don't use 96.66. Put 0.966 in these formulas. Okay. Or you instead of 1, you put 100. Everybody understand that what I'm saying here? So if you have to calculate n, you put 0.966 divided with 1 minus 0.966, okay? Or you can, if you want to use 96.66%, okay? Oh, sorry, my bad, it's not 2, it's 1. My bad. It's 100 divided by 96.66, okay? So make sure you do. By the way, the first one was not 2, it was 1. I cannot now fix it. I think I can. There's an edit option. Okay. So you can see that make sure you follow a consistent one. If it is percentage, use 100. If it's not percentage, use 1. Everybody okay with that? It's pretty straightforward.
Yes.
Formulas will be given to you. Okay. Yes. Any question?
Yeah, how did we get the 1.45 divided by 1.5? This is the mu and the lambda.
Yes. So go back up there. The table.
Yeah, okay, this is the lambda.
This is the average number. You take the average number of customers will give you customer rate because each minute how many customers came, right?
Hmm.
So this will give you 1.45 is average customers per minute. So this is like lambda. You calculated lambda from here, okay?
Okay.
And then these are the average service time taken by each customer. So you take average. So
Hmm.
this gives you 1 over mu because it's the time, not the rate. So then you do 1 over 0.67. So this will give you mu, which is 1.5.
Hmm. And
Okay,
then
Baba?
well, we divide, yes, and we divide them and we get the percentage of the business.
So we'll go back here. So what's the formula for? So I see the chat box. So I said RHO rho equals to what?
Yeah. Rachel.
Lambda over mu. Okay, see the formula there. If
Yeah,
you
yeah,
look at the lecture, you'll find that, which is
yeah,
the lambda over mu.
yeah. The
So it's
P, yes, P
yeah, the
equals yes.
P thing. Yeah, the P thing. So now it's 1.45 divided by 1.5, and that's how you got 96%.
No, okay. Thank you.
Okay. So the question very similar to the one like this. So I'm pretty sure if you can solve this problem, so you so you should be able to solve a full problem. Okay. So once if this is done, now I'm going to move to another one. This one is pretty straightforward. It may look a little busy, may look a little complicated, but please stop me wherever you don't understand. Okay. Stop me wherever you don't understand. There are just very small things you have to take care of, but the rest of the problem, inshallah, will be fine. You have all the background to solve this problem, and I just have to tell. So this problem, I honestly I did not solve it in the class because I thought we'll just be doing a simulation, but the course reader has added classification, classification lecture which we skipped in the midterm exam, and so she added that in the final. So we have something called Bayesian classification numerical. So you again, if you can just solve this particular problem, you should be able to solve the problem exam. So it's just like a replication with another data. Okay. So inshallah, it will not be a problem. So you need to now. Sorry, my throat is really bad, so my apologies for the coughing.
No
So
problem.
so first of all, Uh, there is something called classification and clustering. Do you remember classification and clustering from our midterm, before midterm? So classification, clustering was about grouping, right? And then from grouping, you give names to those groups so that it forms classes. And then something new comes up and you would like to predict whether the new data belongs to which class. Now, this classification can be done in many ways, and one of the ways that uses probability and statistics is called Bayesian classification method, which uses something called conditional probability. Okay, just give me a second. Sira Shahir, beta, please आओ इधर. बस जल्दी आ जाओ बेटा. दरवाजा बंद करो बेटा, नॉइस से मैं डिस्टर्ब हो रहा हूँ. प्लीज मुझे आवाज भैया की बहुत जोर से आ रही है. Yes, so it just uses conditional probability, which you have covered in the class. Okay. So see, first of all, let's just read this problem and then we'll talk about, what exactly are we trying to do. So there are 10 data points given to you. Okay. And there are 5 instances of class labels, uh, yes or no. Okay. So whenever you are given, I think I should start from here. So this data set contains an example of different conditions that are associated with accidents. So, when you're driving on the road, many things can cause accidents, right? So we have picked a problem that is very easy to understand. So our target variable, as we call, is we wanted to predict whether there is a likely an accident or no accident. Is that clear? Everybody understand what is the thing that we're trying to predict? So we have
Yes.
only 2 classes to predict. Accident, no accident, based on 4 features. What are those 4 features? Weather condition, road condition, traffic condition, and engine problem. And each of these features can have different possibilities. Okay. For example, if you see up here, weather conditions can be rain, snow, or clear. Road conditions can be good, normal, or bad, and traffic conditions could be normal, high, or light, and engine problem can be yes and no. So, based on weather condition, road condition, traffic condition, engine condition, we wanted to predict whether there's a high probability of accident or no accident. So, as you can see this table, when there is rain, bad road conditions, high traffic, and even if there is no engine problem, there's high probability of accident. Okay. So are you able to see how we are setting up the data? Are you all okay with the way this data is set up?
Is all of this information given, or do we predict some?
No. So this even in the exam, another scenario will be given with exactly data in this form. Okay.
Okay.
Plus it will be given to you that what is your target variable. The target variable is, or the variable that you're trying to predict, will also be a binary categorical variable, which means that we will be giving you yes and no conditions only. Yes. No, that's what I said. This data will be given to you. So in the exam, this is a data given to you filled. The questions will come based on this data. The questions are still not given. I'm just trying to show you how the question is given, how the data is given to you. I have still not defined, what kind of questions come for this data. Okay.
Doctor,
Yes.
if the data is given in exam, what the question is?
We will come to that. But do you understand how the data is given?
Yeah, you give us a table with the sum of data.
In this data, you must be able to identify what is your target variable and what are the features. This is what I'm trying to tell you, right? So
Okay.
at least you can make the distinction by reading this description given to you. You should be able to tell which column is you would like to predict and which column are the input variables or the features or the categorical features.
Doctor,
Okay.
the future like attribute in the SQL.
They are like this, but feature, look, in prediction, there are some input and there's some output. Okay.
Okay.
Input data is what you are trying to use to predict something, and that something is basically the target variable. Okay. So in
Okay.
simple language, the features, weather condition, road condition, traffic condition, engine problem, I'm trying to use these conditions to predict whether there is a chance of accident or not. Okay, everybody is okay with that? Shall I move on to the questions?
Yes.
Now, there will be three kinds of questions that will be asked to you. Okay. Maybe the names can be different, but I'm going to explain one at a time. One is called prior probability. The other one is called conditional probability. And the third one, which is called posterior probability. Do not get afraid with the length of the question. It's just one thing repeated many times. Okay, so inshallah it will be fine. So the first question is, in prior probability, we may ask you a question, what is the chances of accident or no accident by looking at this data? So what are we trying to ask you is there more chance of accident or there is less chance of accident that we are trying to ask? Now we are, in this case, in this basic case, the first one, prior probabilities, you don't have to look at the features. You just have to look at only the accident column or the target column. Okay. So, I'm trying to ask you, what is the probability of accidents? Do you see what it says? Probability of accidents, yes. And the probability, can you see it here? Probability, let me zoom that in a little bit. I want you to find me the probability of an accident, yes. Probability of an accident, no. How would you find this probability? It's very simple. How many data points you have? And how many yeses you have?
5.
Okay. Okay, and how many no's you have? 5. It's as simple as that. You just have to find this ratio. So why 10 here? Why 10 here? Because your total number of data points are 10. Just see again how many data points you have. 10. Okay. And how many yes accidents were there? So what is the probability of possibility of an accident? Because yes appeared 5 times out of 10. So this is your probability of accident. And probability of not having an accident, again, no appeared 5 times. So 5 over 10. So it's 0.5. Right? You get that? Is that clear, everyone?
Yes, clear.
That's clear.
Yes.
It is as simple as that. So the first step, let me repeat it again one more time. If they're asking about simple probability of the two different, because here I'm asking about accident, maybe there I may ask about gender, male or female. So instead of having probability of accident, yes and no, I may ask you about probability of male or probability of female, or probability of a disease or no disease, right?
So
But that will be the only difference. Yes, Abdullah.
basically we take the average of the probability.
Not the average. The ratio, right? Ratio
Ratio.
meaning that how many of one type occurred out of the total. Yes. Yes, so instead of, imagine if it was male, female, so I would have asked about probability of how many male and how many females. Probability of male or probability of female, then you just have to write it like this. Imagine in your data you had 6 males and you have 4 females, then that's how you calculate the probability. Okay?
Okay.
Let's move on to the next question, which is where it gets not tricky, but you just have to understand that one very small point. Now, there's something called conditional probability. In conditional probability, you use some additional information to improve your results. You need to understand the concept of conditional probability. In conditional probability, you always use some additional knowledge, right, to improve your ability to predict. So that's basically the purpose. So now we will ask, we'll see where is that additional information coming from. Now, let me just go down there and let me show you how conditional probability is given to you. Now, if I tell you weather conditions, just a second. Here, can you see this statement here at the top? No, it's not division. It means given. So if I tell you that, if I ask you a question now, this is where you learn how to write this thing. and how to find the right answer. Okay. So if I tell you that there was no accident, so I knew that there wasn't any accident. So what is the probability that it was a rainy condition? It was a rainy day. You understand my question? So what I have additional information that I have given you is that I'm telling you that there was no rain. So what is the no accident? So no accident is given to you beforehand. Okay. So what is the probability that there was actually the rain at that time? So you already knew that there was no accident. So which means that this yes, 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 you just have to, they are irrelevant to you. Right? Irrelevant, not relevant, irrelevant. I already
No.
told you that there was no accident.
Not important. No, irrelevant means not important.
Not important. Okay. Now you just have to now look at not the 10 data points, but you only have to look at those data points which says no, 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 no. Now it's hard to read, right? So what we have done here is that we have separated this data of no and yeses again for our ease. But if you don't, you just need to make sure that you're looking at only the no data points, when I'm asking this question. Now, when you're looking at this no data points, how many of those data points are there? There are no more 10. They are actually 1, 2, 3, 4, 5, right? Now, in these data points, how many data points do you see with rain? 2. So, what is the ratio here? 2 rains out of. That's exactly what you did. Do you see there 2/5? So now can you tell me what is the probability of snowing given that there was no accident? I knew that there wasn't any accident. So how many snow do you see here? So what is the probability of snow when there was no accident? I mean, it's up to you if what is the answer to that? Okay, can you hear me now? So Hamad is asking why we have 6 rows, because we have six questions. So Hamad, I'll keep asking those questions, right? So it depends on how many questions we are asking. So we can ask, give me the probability of rain given that there was no accident. That will be the question. You understand, Hamad? So this is one question. This is like the second question. So now I'm going to, Hamad, ask you the third question. Can you tell me the probability that the weather was clear given that there was no accident? Hamad, can you tell me, looking at this data, what is the probability that the weather was clear given that, yeah, it's 2/5. That's exactly what you have to do, right? So we keep creating more questions to you. Now, what is the probability that the weather condition was clear given that there was an accident? Now, you should not be looking. Now, I want you to make use of this original table to make it a little bit more challenging. So I say, given what was the question? The weather was clear. What is the probability of weather clear given that there was an accident? So you have to check clear with a yes. So I'm not going to use this one because it says no, yes, clear. Right? Is there any other clear with a yes? Yes, 2 of them, right? Yeah. Not 9, 10. So you just have to be careful. That's it. So 2/5. Or here they have separated the data. You can see 2 clear out of 5. So 2/5. So is that too difficult to handle? I don't think it's too difficult to handle, right? So let's just practice a little bit more. Road conditions good, given that there was no accident. Okay, no accident, and the road conditions good. So what is, who can tell me the probability? Maybe someone else, Muhammad? Road conditions good, given that there wasn't any accident. So Muhammad says it's 3/5. Yeah, exactly. Right. So so you have a lot of them, a lot of examples here. In the exam, of course, you'll not have like how many of them we are here: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we have around 16 examples for you to practice. Okay. In exam, we'll give you maybe five or so. Okay. So let me, before I move on to the last one, so you understand the difference between the two. The first one was called prior probability, where we just have to look at the target, and you have to see how many of one type over total versus how many the second type over the total number of data points. Okay, and then we just saw the conditional probability. So whenever conditional probability is given, the question will always ask given something, given something, given something. Okay. By the way, I can even ask a reverse question. Let me ask a reverse question, and this is where you can be a little careful. I say, what is the probability of, where is our data? No accident given traffic condition was high. Now, how many highs do you see? 1,
4.
4, 4, right? Only one no, right? Do you see the last three? Only one no. No, you have 4 highs, not 5 highs. Count again. 1, 2, 3, 4. Look, this is where I yeah, that's why I asked you this question, so that you understand the question and be careful about it. I said the information I have given is not about the accident. Now I've given you information about the traffic condition. I said, what is the probability of no accident given the traffic condition was high? Okay, that's the only thing, you need to be careful, right? So given what? Now let me just do one last bit, okay? Now one last bit, and this is called posterior probability, is normally asked about something that is not given in the data, about a new feature or new vector. Okay, so because it's not given in the data, so that's why it's outside. So because of outside, so it's posterior. That's why we use the term posterior for it. So uh, this is the third thing, and this is the last thing left. Okay, so now we are asking you weather condition rain, road condition good, traffic condition normal, and engine problem no. The task is to predict if the accident will happen. Now the problem is this exact situation. Uh, so what is the question? The task is to predict if the accident will happen. Okay. So how would you calculate that? So it's asking where rain condition, what is your weather condition? Rain, and accident is will happen, meaning that accident is yes. Now you have already found the conditional probability, right? So can you see the first term here? We know that accident has happened. So the first term is probability of weather condition. We would like to find weather condition of rain given accident has already occurred. But it's not the only thing. We are looking for multiple things, okay? And more information is given to you that road condition is good, traffic condition is normal, and engine problem is no, okay? So in this case, what do? We have, if you look at them individually, those are individual conditional probabilities, right? Road condition is good given accident occurred. Traffic condition normal given accident occurred, right? Engine problem no given accident occurred. Now what you have to do is simply to find those individual conditional probabilities, okay? Are you all following me?
Yes, yes.
Multiply with probability of accidents. So all conditional probabilities multiply by, that's the way you estimate posterior. I have to go into probability theory if you would like to go into detail. You know, whenever you have to have you remember probability. Okay, if you want to discuss that, I can briefly touch upon that. So you have and or that you learned during probability estimation in your probability class. Anybody remember what you do when you have or and when you have and condition? This probability of this or that, probability
Yeah,
of this and. So what do you do?
addition. It's addition with the or. And
Addition with or and
minus
no, not minus, multiplication with and,
oh yeah.
right? So what are we doing here? We are saying that probability of accident, this is probability of accident. We know that accident has occurred. So this is the probability of accident, right? And then we are improving our probability by saying that what is the probability of weather rain given that accident has occurred, and probability of condition good given accident has occurred, and probability of condition normal given accident has occurred, and probability of no problem with the engine and accident occurs. Now you understand? Because of and, right? So probability of accident, because we said that accident has occurred, and weather condition rain given that we knew that accident has occurred, and so on. Okay, now you understand, Sai? So you have to calculate them one by one and you multiply, okay? Look, you calculated, Saeed, you already calculated these numbers, for example, above. For example, you already calculated probability of accident, yes. See here, probability of accident, yes. 5/10, right? Then you calculated probability of go back again, weather condition rain given accident, yes. You just multiply these numbers to get the answer. Because I'm telling you the formula, because this is what is given to you, right? Okay, and then we calculated both with accident yes and both with accident no. Okay, just to tell you, if you have to calculate yes and no. Now, which accident yes, given all these things occurred, what is the probability you got? 10/6250. Can you use your calculator and tell me? 6250. 0.16%. So is this high? If you wanted to check what is the other side to it, no accident, right? So you just calculate the same thing given no accident, no accident, no accident, no accident, and it turned out to be 240 over 6, 240 or divided by. So which one is high? So what is more likely to occur in this case? Or no accident? Yes accident or no accident, which has higher probability? Yeah, so which means that no accident has a higher probability. Yes, Mohammed, no accident. So it's basically what you're predicting here is that if there is rain, good road conditions, normal traffic, no engine conditions, the chances are that there will be no accident. Why? Because it has higher probability. Yes. Sorry, say again.
Individually, they are individual conditions. We're trying to relate to the accident itself individually, and
Yes.
then we multiply.
Yeah, that's exactly what we are doing. These are the question. Look, the question is asked if there is rain, good road condition, normal, and there is no engine problem, is there a more chance of accidents occurring or less chance? No chance, no accident occurring. So you found it with yes accident and no accident, and then compare their probabilities, and you say that no accident probability is higher, so that's how you concluded that there's because there's higher probability of an accident, that's why the chances are there will be no accident. So khalas, so this is kind of a problem that can come. Is that clear to everyone? We will go to that lecture. Say just a second. We will go to the other lectures, but let me ask you about this thing. Everybody is okay with that? Please, this question. Others as well.
Yes.
Now the pattern of the question will be the same. This data will be given to you. Instead of accident, you may have something else, and features might be something else. That's the only difference. Okay.
So I
So
have one question.
yes, Abdullah.
Victor, now when you ask first if you have high and one no condition, why we put 4/1 or 4/5?
Say again, which one?
Traffic condition high.
Okay, 1/4. Why did we put 1/4? Okay.
Why 1/4? Yes.
Okay, so you need to understand what is the given information. Given information, the last time when I asked, it was not about accident, it was about traffic conditions.
Oh,
So,
okay. So we calculate it over the traffic condition.
so how many highs do you see?
4.
And I said, what is the probability of accident, of no accident, given that the traffic conditions was high?
So we calculate it according to the traffic condition.
Yeah, because that is the thing given to you.
Okay.
هذا المين condition تبني عليه.
Yeah. So this is whatever is given to you is what you use. Okay. For example, can you tell me the probability of accident given that road conditions are bad? We know that given road conditions are bad. So how many bads do you see?
Bad, 1, 2, 4.
4. And for each bad, how many yes do you see?
Yes. 3.
See, 3. So what is the probability of accident given road conditions are bad?
3/4.
3/4. That's how you calculate.
Thank you, Doctor.
It's clear to you?
Clear. Thank you.
So you always go like this, the ratio of total over whatever is given. So if this is clear to you, I'm very confident that inshallah the problem portions are going to be fine with you. Okay. So now let me just stop sharing. Okay. So then the question. So these are the two main problems. Okay. Now in MCQs, you basically have to okay. You have the recordings with you. Okay. Make sure other than simulation, within simulation, there is a lecture on probability and statistics, lecture 1213. Okay. It has those basic information which you already know very well. Okay. About mean, median, mode, variance, bar graph used for what, it just the basic things. If you still feel before the exam any problem with that thing, we can still gather again. But please make sure you read that as well. The simulation chapter 10, 11 is very important. All the things that we see, verification, validation, because the rest is just MCQs. So we're just talking about MCQs. Okay. Hierarchical clustering, please make sure you read hierarchical clustering. Complete linkages, look at the example of how we are creating the hierarchical clusters. You need to know the distance between similarities and dissimilarities in the data, data conversion, binary and categorical. Please make sure, because it has been some time, so I want you to look at it, because I cannot cover everything in it's already 10 o'clock. So your exam is on Sunday, right?
Yes.
Yeah.
So please start preparing, and if you face any problem, I'll be more than happy that we have another session on weekend or something.
Thank you so much for the session, doctor. And you look sick. We hope to see you getting well soon.
اي والله.
Yeah. I wish I could continue. I'm so out of energy, out of
No,
fuel.
it's obvious. It's obvious. It's obvious. We can see.
You're
Yeah,
doing
last
above your
season-
you're doing above your job, Doctor. Oh, thank you so much.
No. I think I did less this time to all of you. I wish I could do more. But I really want you all to succeed, inshallah, in this exam.
Inshallah. Just a quick question, doctor. The files that you provided Muhammad with, just to clarify, do we only study those files for the essays? Is it enough?
I want to be very efficient, so yes, the straight question is yes. The question pattern, if you understand the question pattern, the question will be very similar, inshallah.
Thank you so much and get well soon, inshallah.
Thank you so much, and best of luck. And please study those lectures, collect questions. You can send those questions to me as a collection, not individually, because too many things going on in both universities. So I'm very struck. I usually I respond quickly, but this time I'm really bad in responding, simply because of extremely overloaded situation. So please collect questions, and maybe one of you can send it to me, and I'll try to reply those collection of questions through maybe Muhammad. Okay. Otherwise, if you send me individual question, I'm not sure if I'll be able to respond quickly to each one of you. Okay. So please collect 3, 3, 4, 4, 5, 5 questions. You discuss in the group, send it to me, and I'll collectively respond to that, and then maybe Muhammad can forward my answer to all of you. Okay. Yes, sir. I discussed quite a lot in the class, Saeed, and there is a recording. You will get full explanation again. My throat is completely gone. I'm very struggling to speak now. So, like Mohammed said in the chat box, when you see independent arrival and independent service, that's basically MM1. How many marks? Jawad is asking how many marks for multiple choice questions. Well, the answer is you have 20 marks for MCQs and 20 marks for the questions. So 10 marks for the problems. Okay. So 10 marks for the two problems that I just did, and 20 marks for the MCQ. All right. So the lectures are there. Please read those. You can listen to those lectures. Prepare for the exam, and if there's anything, then as I mentioned, please via Muhammad, please send me your questions. And then if required, if you have more questions, I'll be more than happy to have another session like this. Okay. Which lecture? I already gave you that lecture now today, because that was the part I first thought I'll record, but then I gave it here about the classification problem. Okay. So thank you everyone, and inshallah we'll talk again.
Thank you so much, Dr. Allah. Thank you. Let's
Thank you.